In this chapter, we're looking at the ways we can represent data graphically. So 2.1, we're starting off with looking at qualitative data. In other words, categorical data. So when we don't have numerical categories, it's more of, colors or that type of categorical settings. So we mainly have counts of those categories. So the way we would look at this is mainly with a distribution, how that data is distributed among those categories. And we'll discover the idea of statistical tendencies. One way we can look at qualitative data is through bar graphs. This is very useful for summarizing one or two qualitative variables and making comparisons between them. Bar graphs can either be vertical or they can be made horizontally. You might hear of Pareto Charts. That's just a bar graph that's ordered from largest to smallest. So instead of having a graph like this one, this is courses, chemistry, physics, economics, they would have put maybe the economics first because it's the largest bar, and then descending order. That's all that means. And we can either have the markers here being the exact frequencies. Notice this one has the exact numbers, the counts of how many are enrolled in each of the courses. Or they can be what is called the relative frequencies. That would be the proportions or the percentages enrolled. Now, when we're looking at these, we're looking at their distribution. That's referring to the patterns. Distribution means the variable's possible categories and the proportion of responses in each. Another way we can represent these is with a dot plot. And that's just where we put a dot for each count for a certain category. Now, it's easy to create a dot plot if we have a small sample size. But if we were talking about enrollment in courses and we're talking about hundreds of students enrolled in a course, I would not want to put hundreds of dots in a dot plot. So if we have a very large sample size, a dot plot would not be good. A bar graph would be preferable. We can also make pie charts if we're showing the relative frequencies. In other words, the percentages can also be shown in pie charts. So these are the three main ways we can show graphically qualitative data: bar charts, dot plots, and pie charts. So in our first example, we have a side-by-side bar graph. That's just meaning we have data represented all in one graph. So side-by-side bar graph representing feelings toward the internet from parents of 12 to 17-year-olds for the years 2000, 2004, and 2006. So the first bar is 2000, 2004, 2006. 2000, 2004, 2006. Participants in a survey were asked, overall, would you say that email and the internet have been a good thing for your child, a bad thing, or haven't had much effect one way or the other? So, can we interpret a bar graph? What proportion of parents felt the internet was a good thing for their children in the year 2000? So 2000 is the bar on the left side. It's the first one. So in 2000, that'd be this one, good thing. 55% of parents said it was a good thing. What about in 2006? That's the last bar. So in 2006, 59% of parents said it was a good thing. I'm just going to... Which opinion saw the greatest increase between 2004 and 2006? So between the middle and the last. So here we have a decrease. Here's an increase. And here's an increase. So we have an increase here of 5%. There was an increase of 5% between 2004 and 2006 among parents who had no opinion. Does a decrease in the percentage of parents who view the internet as a good thing, so right here we have a decrease, necessarily correspond to an equivalent increase in the percentage who view the internet as a bad thing? So we have a decrease here of 8%, and here we have an increase of 2%. So is this increase and this decrease mean necessarily that they think it's now bad? No, because we had 5% change to I really don't have an opinion now. So not necessarily. Why might the percentages within each year not add up to 100%? So let's take, for example, the year 2004. The first bar was 67%. The next one was 25%. And the last one was 5%. If I add those together, that's 30 plus 67, that's 97%. Why are they not adding up to 100%? What happened to the other 3%? So let's think about that. Could it be that 3% didn't answer? Could it be that 3% chose another option or something like that, or wrote in something different? We don't know. But just remember that sometimes your data can be misleading based on your questions or based on non-responses. Okay, we have a dot plot next. The following dot plot displays the distribution of daily high temperatures for the month of February 2006 in Lincoln, Nebraska, San Luis, I can't say that word, California, and Sedona, Arizona. Which city tended to have the highest temperatures that month? And which city tended to have the lowest temperatures? So let's look. Which one has the highest temperatures? Well, it looks like the city in California had the highest. And the lowest, well, that looks like Lincoln, Nebraska. Which city had the most day-to-day consistency in its high temperatures? So let's think about what that means, consistency. Consistency would mean that the temperatures are staying around the same number not spread out very far. If it's consistent, it's staying around the same number. So which one is the most consistent? Well, notice that Sedona is staying between 50 and 65 mainly, while the other ones have a wider spread. So this would be Sedona. Which one has the least consistency? So which one is spread out the most? That would be Lincoln. Now here's an ad or a chart from USA Today. And it shows the most frequent cosmetic surgeries for women in 2006. If women had 1.9 million cosmetic surgeries in 2006, what percent were for tummy tucks? So let's look at the number we have for tummy tucks. There was 146,000 tummy tucks. So 146,000 out of 1.9 million, that'd be 1/900,000. Let's see what that percentage would be. So 146,000. Let me put my calculator on the screen. 146,000 divided by 1,900,000. I get 0.0768. But what is that as a percent? That would be 7.68%. What percent were for nose shaping? So nose shaping is 307,000 divided by the 1.9 million. I get 0.161, that would be basically 6, which in percent would be 16.16%. How many surgeries are not accounted for in the graph? So what if we added up all these surgeries? 329. Well, since they're all in thousands, I'm just going to do 329 plus 307 plus 303 plus 233 plus 146, and I get 1,318,000, right? And we said there's 1.9 million. So 582,000 are not accounted for. Does that change your view of this graph? Is this graph misleading? 582,000 surgeries aren't even shown in the graph. But it makes it look like these take up a very high percentage when this one was only 16% of all surgeries. Very interesting note to make of how charts can be very misleading if you're not including all the information. The following data represent the percent of owners of an electronic device planning to purchase a replacement device within the next 12 months. Now I invite you to try this example and the next example, and then so press pause, Try them, come back, and see how you did. What % of game console owners plan to buy a replacement device within the next 12 months? So game console owners, that's 10.5%. If there were 250 million Americans in 2007 who owned a cell phone, how many expect to replace the phone? So the cell phone was 14.9%. So I need to do 14.9% of 250 million. That means I need to multiply 0.149 times 250 million. Woo, 37 million people. We have dot plots of the number of hours a class of students exercises each week to the number of hours a student plays video games. Which category tends to have the highest number and which has the lowest? Well, the highest number is 14, and that's in video games. And lowest, well, since they both have a 0, I'm going to go to the next. We have lower values in exercise. Which category has the most consistency in the data? Which one is less spread out? I would have to say video games, I think. In a study conducted by the Better Business Bureau and Javelin Strategy and Research, victims of identity fraud were asked, who was the person who misused your personal information? This should be quotes. I forgot to fix that. The following bar chart represents the results for cases in the year 2006 for which the perpetrator's identity was known. People who misused personal information. And these are relative frequencies. These are percentages. Think of this as percentages. So 0.05 is really 5%. This would be 10% and so forth. Approximately what percentage of identity fraud victims were victimized by someone who obtained their information on the internet? So we need to go through and kind of guesstimate what these numbers are. So this one's just shy of that 5% line. So I'm going to guess 4%. This one's just a little past. So I'm going to go with 6%. This one's just a little bit further. So 7%. This one's at the 20% line. 1, 2. This would be like 22%. 25, 26%. Okay, so internet, that would have been 7%. If there were 8.9 million identity fraud victims in 2006, how many were victimized by a service employee? So service employee was 20%, so 0.20 of, I'll just do 8.9, remember that's in millions. I got 1.78 million. Can the data presented be displayed in the pie chart? Well, what do we need for a pie chart? If we're drawing this as a pie chart needs to add up to 100%, right? Let's see what we have. We have 4, you can't see that either, plus 6, plus 7, plus 20, plus 22, plus 26. We have 85%. So we only know 85%. 15% is unknown. So we would need to know something about that 15% to be able to make a pie chart. Okay. The following table lists 20 responses to a survey about the reasons for visiting a local library. So study, meet somebody, check out books, and so forth. So what we can do is kind of consolidate and write down the different reasons. One reason was to study, meet someone, and check out books. So how many times did somebody say they were going to study? 1, 2, 3, 4, 5, 6, 7, 8. So my count is 8. Meet someone. 1, 2, 3, 4, 5. I think that's 5. Check out books. 1, 2, 3, 4, 5, 6, 7. Now, making a bar graph, we could do it by hand. And so I'm going to do it by hand, and then I'm also going to show you how you can do it in the calculator. 1, 2, 3, 4, 5, 6, 7, 8. So the first bar is going to be study, and it would go up to 8 because that was the count. The next one was meeting, and it only went up to 5. And check out books went up to 7. And that's how you would make one by hand. Now, if you wanted to do that in the calculator, especially if you had larger data, I wanted to show you how you could do it. So I'm going to press, we're going to go to Stats, and we are going to edit. Now my data has data in there. I'm going to clear this out. So I'm going to show you how you can clear this out. So there's a clear button, but I'm going to go up to where it says L2 and press clear, enter. What that does is it clears the list. Clear, enter. If yours was already clear, then you're good to go. Since this is categorical data, I can't really type in the labels. All I can do is type in my counts. And we want to look at a plot. We're going to make a bar graph. So first off, I need to make sure there's nothing else that's going to show up on my graph. So I'm going to press Y equals, and I do have something in my graph. I'm going to turn that, press clear, and clear that out. Since we're in statistics, we're going to go into stat plot, and it's in blue over the Y equals. So I'm going to press second Y equals, and I'm going to go to the very first option, plot 1. I want to turn on this graph. Now it tells me what I need to pick a type. The first type is a whole bunch of little dots. That's a scatter plot. This is a connected dot. This looks like a bar graph, and it is. And now I'm going to go to my graph. But I have to be careful here because the window's not going to be right. So I'm going to press zoom. And zoom stat matches the window with what we're given. Uh-oh. Hold on. It did not do what it's supposed to do. So hold on. I did something wrong. I apologize for that. I was having a brain damage moment. So in L1, I just put category 1, 2, and 3. And I put my counts at 8, 5, and 7. Much better way to do this. Now I'm going to go back to stat plot, and my list is in L1. That's my categories. And their frequencies, their counts, are in L2. 8, 5, and 7. And we had selected the bar graph. Now I'm going to press zoom. Oops. Well, not right now. I'm not. Hold on. Zoom. And then I'm going to go down to that zoom stat just to make sure my window is exactly what it needs to be. And I get a graph that looks very similar to what we did here. Now for qualitative data, I find graphing them by hand is actually easier than trying to put it in a calculator. You noticed I even messed up trying to put it in the calculator because it is easier to do by hand.